Starting with the first question, and this is a very common question on the ACT. It says that in the figure below, C is on BD, which we can clearly see that. BAC measures 35 degrees, again, we can see, and that ABC is 95. The question is what is ACD, or where the question mark is. One of the important things to remember about triangles, and you probably remember this from your class, is that there is 180 degrees in every triangle. So if that's true, then I should be able to take 180 degrees, subtract 35, subtract 95, and that leaves me with 50 degrees for that angle right there. Now, another important thing that you want to remember is that if you have angles that share or sit on a line together, that also makes 180 degrees. So if this side is 50 degrees, subtract that from 180, and the other side is 130 degrees, which is answer H. Here's another one. Remember, I said this was a very common question. If you'd like to, pause the video, try it on your own, and then come back and check with me. So in this one, again, we're given these two angles and asked to find this angle right here. We again remember there's 180 degrees in every triangle. So therefore, we're able to take 180 degrees and minus the 65 and minus the 30, and that leaves us with 85 degrees for that angle right there. Recall that if angles sit on a line together, a line makes 180 degrees. So if this side is 85, subtract that from the 180, and you get 95 degrees for the other side of the line. On number 23. It says in the figure below, E is on CA. Clearly, I see that. It gives me the measures of these two angles, 145 and 90 degrees. Hopefully, you remember that if you have that symbol, that refers to a right angle, which is 90 degrees. The question says, what is CED, or this little angle right here with the question mark? Again, let's go back to the fact that we know if two angles or even more sit on a line together, that makes 180 degrees. So if this side is 145, subtract that from 180, and that gives me 35 for this other little part right there. Now we said that this is 90 degrees. That right there is 90 degrees. So if this part of it is 35 and we want the other part, just subtract. 90 degrees take away 35 degrees is going to leave me with 55 degrees for the other side. So the answer is C. Number 25. The triangle below, A is 58 degrees, they tell us. Now here's something we want to make sure we catch. AB is congruent to AC. So we're going to mark our triangle. AB is congruent to AC. What this tells us is that we have an isosceles triangle. Isosceles triangles are triangles where these two sides or legs are equal to each other. And if these two sides are equal to each other, that puts these two base angles also to be equal. It's sitting on its base, and that's the angles of it. So that would mean that these two angles have to equal each other. Again, 180 degrees in a triangle. So 180 degrees, subtract off your 58, and that's going to leave me with 122 degrees left to be split between those two equal angles. So split it, and that means that 61 degrees is what each of those angles are equal to. Number 5. In the figure below, AB is congruent to BC. So we have another situation where this is equal to this, making us once again have an isosceles triangle. It asks for the measure of B, where the question mark is. All right, so the only thing we have to go by is that this angle right here is 26 degrees. There is another thing in geometry that's very popular and common on the ACT, and that's something called vertical angles. Vertical angles are equal to each other, and think V vertical angles, which would be these two. Do you see how they're V'ing up to each other? So they kind of make a V with each other, but vertical angles are equal. So if that's 26, that's 26. But because it's an isosceles triangle, if this side's 26, the other side is 26. Knowing what else we know about triangles is that that's 180 degrees total inside there. So 180 degrees total, take off that 26, take off that 26, is going to leave me with 128 degrees for that angle at the top, which is what they want us to find. All right, let's take a look at the next one. This one right here. It says in triangle ABC, the measure of ABD is 70, so we can see it. The measure of ACB is 32. We see that. D is on BC. Clearly see that too. Now here's something, if I'm not careful with my reading, that I might miss. AD is a bisector of BAC. That's telling me that this AD is going to bisect this angle. Bisect means to cut in half into two equal parts. The question says, what is the measure of ADB? Notice they don't have a question mark in the problem like they do a lot of times, so let's make sure that you can feel comfortable like identifying what angle that is. Just start with A, go through D, and end up at B. Just kind of read it across, A to D to B. So start at A, go to D, and then B. So we're talking about that angle right there, A, D, B. So that's where our question mark is going to be at, right here. So to do this right here, we're going to step back and look at the big picture. We're going to realize there's 180 degrees in this huge one big triangle. So if this angle is 70, this angle is 32, I can subtract from 180 to find out what this angle is, which is 78 degrees. But remember what it told us about this angle right here. It told us that this angle was bisected into two equal parts. So 78 bisected into two equal parts makes each side be 39 degrees. Then we'll go back to the fact that there's 180 degrees in this triangle. So I'll take 180 and I'll subtract off the 70 and subtract off the 39, and that leaves me with 71 degrees for this angle right here. Number 32. In the figure below, AB and CE intersect at O. I can obviously see that by just looking at the picture. Then here it tells me something that I would want to make sure that my eyes read. OC bisects BOD. So OC bisects B to O to D. That means this angle and this angle are equal to each other. The measure of AOD is 40. They tell me that. And they want the question mark AOE. All right, let's go back to something we did in some earlier problems. Do you remember in some earlier problems we said angles that sit on a line make 180 degrees. So if this angle is 40, subtract that from 180, and that means this whole thing is 140 degrees. That way 40 plus 140 total to 180. But we're told that this angle right here, remember, is bisected. So if 140 is the whole thing, each of these would have to be 70 degrees. Then I want this, remember what we said about vertical angles. Vertical angles V up. That V's with that. And they are equal. So if that's 70, that's 70. And my answer is J. Number 41. In the figure below, AD, BE, and CF all intersect at Z. I can see that. And the two angles are given. The question says, what is the measure of CZE? So start at C, go through Z, and stop at E. So C to Z to E. This is the angle that we want. All right, so to go about that, let's think about this. There's a vertical angle that's V and up. So if that's 51, this angle is 51. All right, then let's go back to the fact that we know these right here, that's a line. That means that is 180 degrees. So 180, subtract 25, subtract 51, leaves me with 104 for that angle. Now remember what the question's asking for. The question is asking for C to Z to E, this right here. So that's going to be 104 plus whatever this angle is. Well, he is V-ing up or vertical to 25. So if that's 25, that's 25. And together 104 plus 25 is 129 degrees, or answer E. Okay, let's take a look at number 6. And this is going to move into another topic that's very popular on the ACT. In the figure below, C lies on AE, BD, and AE, and then it tells me DE, they're parallel and congruent. The big deal is that this is parallel, because if I have parallel lines, that's going to open up a whole new set of relationships with angles. So it wants to know what A, C, B, or where the question mark is. Now, when you have parallel lines cut by a transversal, so to speak, or cut by a line, these angles right here are called alternate interior angles. Alternate interior. Alternate, think how it jumps over. See this line? I'm jumping from one side to the other side. That's the alternate. Interior is just because they're inside these parallel line walls. So if this is 45, this is 45. Then I'm going to use the fact that there's 180 degrees in every triangle. So if this angle right here is 45 and this angle is 65, subtract those from 180, and that's 70 degrees. If this is 70, this is 70. Remember the vertical angles that V up. So 70 degrees is my answer. All right, look at number 2. In the figure below, we have parallel lines again cut by a transversal. So here are parallel lines, and we've got relationships here. There's a couple different ways to approach this problem. It just depends on which way you see it. If you remember that this angle and this angle are equal by corresponding angles, go that route with it and set them equal. But if you don't remember that, you could do vertical, how those V up. So that's 135 because it's vertical. Then we could do the alternate interior angles again. This one and this one. See how it alternated or jumped over the line, and they're interior. They're inside those walls. So they're equal. So 135 is equal to 2x plus 5. And then you just have a very simple equation to solve. Subtract your 5 over. So 130 equals 2x. Divide by 2, and x is 65 degrees. Answer J. Number 20. In the figure below, M is perpendicular. That just means you have a right angle there. And we've got parallel lines again. The lines that look parallel are the parallel lines. So this is parallel to this right here. They look to be parallel. So I know that this is parallel to this. So I'm going to be able to use my alternate interior and all of those kind of things. And so what is the measure of x? Well, a couple ways. This is 32. So this is 32. I'm going to use the V up vertical angles. Then I'm going to go alternate interior. So when I went vertical to alternate, see how you're jumping over the line, alternate interior. Then I'm going to remember the fact that angles that share or sit on a line make a total of 180. So if this side is 32, I'm going to subtract from 180 and find out that that is 148 degrees. Okay, let's look at number 5. In the trapezoid below, AB is parallel to CD or DC. So I've got the parallel things going again. What is the measure of C? Well, on this right here, you might remember the fact that angles that are where there's parallel lines, these two angles that are kind of beside, notice I didn't alternate. I didn't jump over there. I stayed right on there. They total up to 180 degrees. So just subtract from 180 and I'm going to get 95 degrees. Now, I do want to share with you a little something that I have a whole nother video on, a strategy video called Trust Your Eyes. The ACT says it's not drawn to scale, but it's pretty much drawn to scale. So you can trust your eyes. And if I were to look at this angle right here, it appears to be just a little sliver more than 90 degrees. It's a little bit more than a right angle. So therefore, it can't be this. And it's just a little bit more than a right angle, not a lot of bit more. So even by eyesight, I might say, yeah, that's 95 degrees. All right, let's look at number 13. On this particular question, they give us some parallel lines and a whole bunch of angles, and they give us these statements right here. And we need to see which statements are true, which one must be true based on the properties we've been talking about. 1 and 5. There's nothing that I can say for sure that make those equal to each other. They're not vertical, so that's not going to work. 2 and 1. There's nothing that I can say for sure that make those equal. That doesn't tell me that it bisects, so I'm not going to do that one. 3 and 10. Again, there's nothing that I know about a relationship. I don't know that that's an isosceles triangle. That those don't even quite look equal either. 4 and 2, again, those are not V and up. They're not vertical. But when I get to this last one, 5 and 8, 5 and 8, those are alternate exterior angles. Alternate because you see how we jumped over the line? They're just exterior because they're on the outside of the wall. So that would be answer E. Okay, let's take a look at number 26. On this one, we're getting into some questions where variables are coming along. It wants the measure of R. So what we want to do is we want to go back and use the fact that we know there's 180 degrees in this triangle and set up a relationship. X plus 3x plus x plus 5 is equal to 180 degrees. So solve your equation. 1x plus 3x plus 1x is 5x plus 5 is equal to 180. Subtract your 5 over. 5x equals 175. Divide by 5, and x is 35. Now that's the value of x. But this question says, what's this right here? So I can let this x go live in his houses. So that means this angle is 35 degrees. Now I can put that 35 and say 3 times 35, and 3 times 35 would mean that this angle is 105. So if that angle is 105, remember how they sit on a line together? And if that's 105, subtract from 180, and that's 75. Then use the fact that this triangle is also 180 degrees. So take 180 minus 35 minus 75, and I'll get that that angle is 70 degrees. All right, last one, and this is a number 60 on a test. Although it's number 60, it's not the most difficult question on this test. All you have to do is draw the picture and then just simply solve it. So it says PK bisects LPN. So the first thing let's do is let's draw an LPM. So an LPM angle, L to P to M. And PK bisects it. Bisects means cuts it in half. LPM, the whole thing, is 11x. And LPK, LPK, is 4x plus 18. Well, if that's 4x plus 18, the other side is 4x plus 18, because remember it bisects it. That's two equal pieces. And then you just have an equation to set up. 4x plus 18 plus another 4x plus 18 is equal to 11x. Put your like terms together. 4x's plus 4x's is 8x's. Plus 18 plus 18 is going to be 36 is equal to 11x. Subtract your 8x over. 36 is equal to 3x. X is equal to 12. Be really careful here, because you could be tempted to put 12. But the question doesn't say what is X. It says what's the measure of KPM. K to P to M. So we have to let that X go live in his house right there and say 4 times 12 plus 18, and that's what gets us our answer, which is 66 degrees, or K. If you'd like more help and practice with ACT Math Prep, be sure to check out the other videos on my channel. Also, remember to like and subscribe and even share with a friend. See you later.